Good morning, everyone. My name is Ina Aparicio. I'm a marketing manager here at EDB. I will be your host today for a webinar, Advances in High Availability for PostgreSQL in the Enterprise. I am joined here by John Dalton, who is the Senior Director of Product Management at EDB. Before we turn it over to him, I'm just going to go over two housekeeping items. So one of them, this presentation is being recorded, so we'll be sharing the recording and the slides after the webinar. Also, the lines are currently muted, so if you have a question, we have a Q&A tab here where you can drop your questions. So at the end of the webinar, we'll still allow some extra time if there are any questions that rise at the end. Otherwise, we'll just follow up with you if you have any question that was not answered. And with that said, I will hand it over to John to kick us off.
Great, thanks, Ina. Thanks everyone for joining today. As Ina said, we'll try to answer questions as we go, but we definitely have some time at the end to get into any questions that you might have along the way. So with that, I just want to mention I'm the product manager for BDR and the solution stack around it. Wanted to jump into the presentation today and talk about what we're going to learn. First off, just want to focus on what I hope you take away from the presentation today is that if you have top tier enterprise applications, you should come away from this with the confidence that you can run those with always on Postgres clusters. Another thing I hope you take away from this is that with this latest release of BDR, we're delivering faster throughput, larger clusters, and better observability. And then on top of that, the last point here is that if you're looking to migrate Oracle applications to Postgres and you have those top tier 5 nines of availability requirements, you'll be able to do that as well. So that's what I hope you take away from today's session. In terms of what we'll go through, we'll talk about enterprise needs for highly available Postgres, and then we'll go through the faster throughput, larger clusters, better observability, and the other enhancements around support for high availability around Oracle SQL compatible applications. And then we'll wrap up with a quick look ahead at the product roadmap, and then we'll have time for questions that we might not have addressed along the way. So to start off, I wanted to talk through what it means to be always on. And I think everyone experiences this every day with our phones and apps that we have. Just to take a few examples from some different industries, like so in finance, we can look at payments that we might make. So if we go into a store or we buy something online, we expect to be able to transact business. We expect to be able to pay for something, and that payment provider behind all of that is always available, right? If we can't make our payment on our credit card, that's not a great situation, right? So that's an example of an always on type of service. Or another thing might be paying somebody and I want to make sure that transaction hit my bank account. I should be able to look on my app and see that that's happened. Or so all of that is what we might consider always on. In telecom, we can talk about video conferencing like this. We expect Zoom to work, or for placing a call or texting, we expect that to be routed and delivered and always available. In the transportation sector, we might, when we're doing travel arrangements, we might be making reservations, checking flight status, things like that. We expect that information to always be available and up to date. If we're looking to arrange a ride through Uber or Lyft, again, same thing, be on our phone, find the car, and have that happen. And then finally, if you're actually driving somewhere, you want to rely on GPS to give you the right information and traffic overlaid with that so that you can be routed around any kind of delays that might be in the way. So those are just some examples of what it means to be always on. We experience this every day, and you're probably part of an organization that's looking to deliver something like this. So if you are a part of an organization that is delivering a service that needs to be always on, here are some of the things you probably need to consider. First, the cost of downtime in terms of reputation to your business. If you've, going back to my example of a payment with a credit card, if you go to pay with a credit card and it has some sort of error, you're not going to probably use that the next time. And that credit card is probably going to move to the back of your wallet. You might talk to your friends and family and say, hey, I don't know what's going on with blah, 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 but you might think about somebody else. That's the kind of reputational impact that not being always on can have to your business. Another thing to think about is, is it okay to have downtime for your application? I have a local bank and they do maintenance upgrades Sunday morning. So every once in a while, there's some maintenance time where, I can't do certain things online. It's okay for me because, I'm not really doing a lot on Sunday morning. So that's okay. But, if I had to make a payment, that's not really a good thing to be down. Another thing is your service tied directly to revenue generation for the business? That's going to be a big thing that comes up in conversation, right? So going back to payments, if I can't make a payment or I can't transact business, I'm not generating business, I'm not generating revenue. That's a problem, right? So that being a problem, meaning you might have a need to be always on. And then finally, do you have customers that are globally distributed? If I'm traveling somewhere else in a different region, if I need to get access to my bank account and it's down because it's Sunday morning here, and then that's not really a great situation. So again, you have to understand where your customer base is and the need for being always on. So just to kind of frame up the conversation about what enterprises are looking for and what it means to be always on. So with that background, I wanted to talk a little bit about what BDR is in case you haven't heard about BDR. And it's really that infrastructure that can enable those highly available applications that might also be geographically distributed workloads. So it's bringing that to Postgres clusters. Fundamentally, it's about logical replication of data and schema. It's a standard PostgreSQL extension. If your application has different consistency needs, BDR can support that. And then there's also tooling that goes along with BDR to help monitor performance. We'll talk a little bit about that later. There's a consistency validation tool. There's ability to manage conflicts, and as well as being able to deploy to the environments you operate in. So that's just a quick overview of BDR. We'll talk more about some of the features later. Now, BDR is not a new thing. The team that's been working on BDR has been involved with the PostgreSQL community for quite some time. So if you go back to physical streaming replication, which everyone is using today to support 3 nines of availability, that's where the team's history comes from. They've been involved with that, and now they've been bringing a lot of their expertise to logical replication and logical streaming replication. And in fact, with version 14 of PostgreSQL, one of the contributions from the team is around streaming large in progress transactions. So the BDR team continues to innovate, and as things get it in place and proven through BDR, that they tend to get fed back into the community PostgreSQL. So we're very much part of the community and contributing to the community. And I just want to also mention that the team has been in place for a significant time. So we've developed quite a bit of expertise around this capability. So this is all good, but now, enterprises are asking for more. Like, there's a lot of great stuff, but, we need more is what we hear. First and foremost, like being able to push as many transactions through the cluster, running as fast as Postgres can run. So that's a thing we hear from customers. If I have a geographically distributed application and it might have really high read scalability requirements, how do I get that without increasing overhead of my infrastructure. And then an observability front. How do I make sure the right data is being exposed so I can quickly triage issues and facilitate recovery actions, right? So that's another area. And then a lot of customers are migrating off of different technologies, Oracle being a major one. And if those tier 1 applications that have those 5 nines of availability requirements, this now is a place where we can talk about being able to support that movement off of Oracle to Postgres. So we'll cover that a little bit as well. So those are 4 areas that I hear a lot from enterprises where they're asking for more. So let's dive into faster throughput and what it means. So before I get into the details of the slide, I wanted to talk just a little bit about the representation of the BDR architecture on the top right of the slide here. So this is what we call our always-on architecture. So it's a classic active-active or 2x2 type of architecture. So we have nodes deployed in multiple data centers or regions, and they're connected through a mesh topology. So each node is sending changes to the other nodes. Typically is just an HA type of deployment. You'll have the application active in one region and it's writing to one of the nodes in that cluster. You might have the multi-region or global application where there's writes happening in multiple locations, but for HA purposes, let's just consider the application active in one data center. So that's it, quick overview of what the always-on architecture looks like. Now, the improvements that we've brought around faster throughput is introducing a parallel data flow architecture. And some of the goals here are around smoother latency, having less CPU overhead on the upstream nodes, and then just overall better throughput for workloads that are parallelizable. And in this release, we're talking about 2 specific capabilities. One is this upstream impact that we get from a feature that we're calling single decoding worker, and then the downstream impact of being able to apply changes in parallel. I've got a couple slides following that kind of go into the architecture, so we'll get a little bit more details there. But one of the key points I want to make on what we're seeing with parallel apply is that we're seeing up to 5 times faster throughput. Again, it depends on workload. So, it benefits certain workloads more than others, but up to 5 times faster throughput on replication over that same version of Postgres or our previous version 3.6. So it is a significant improvement and advance in throughput for us. So let's go into a little more detail in terms of what these look like. So our architecture in our stable release of BDR 3.6 looks like this. On the upstream node where that application is writing to, we have logical decoding happening, basically decoding what's been written to the write-ahead log. And we're doing that for each of the downstream nodes. So there's 3 wall sender processes, each doing the decoding and then sending those changes to the downstream node. So there's then for each of the downstream nodes, it takes those changes and applies them in a single threaded way. So there's one BDR writer process there. So that's the situation as we see it in our previous version. And now let's go to what it looks like today in our 3.7 version. In this case, we're now doing the decoding once, that's the wall decoder. And then we're creating an intermediate format called a logical change record that is used by the wall sender processes to then transmit to the downstream nodes. So that provides us a benefit in terms of the CPU of only decoding once, and then managing on the downstream node to take those changes. And now we see a BDR writer in parallel, 4 of them in this example, applying changes to that downstream node. So we've done some parallelization upstream in terms of the wall sender, and then downstream for those BDR writer nodes. I see a question in the chat around, is the LCR open source? Not at this time. I don't know if you had a chance to catch our Postgres Vision webinar from my colleague Ashutosh. He's one who's working on this, but he went into great detail in our Postgres Vision conference around what that looks like. So I point you to that for now. Now let's move on from that. So moving to larger clusters, what are we talking about here? So I'm going to talk about a particular use case. We're calling it data distribution. And there's two components here. One is a requirement around having high read scalability. And that's where we're seeing this global application. Let's say, for example, from telecom, we're routing traffic, and we need to have metadata about the network so we can efficiently route that traffic. That would be an example of an application that has that need. And then there's some capabilities that we've made available recently that support this ability. We were just talking about single decoding workers, so that's one part of it. And then we'll talk about subgroups and subscribe-only nodes in this upcoming slide. So first, subgroups is a new capability, and it's kind of a foundational aspect of BDR. In our previous version, 3.6, a cluster, all the nodes in the cluster were part of one group. So that mesh architecture minimizes latency between the nodes. But we needed the ability to have more complex support for more complex architectures as we go into the future. So we've introduced the subgroup capability into the foundation of BDR, and allows us to introduce some different architectures and how the nodes interact within a subgroup and then across the group as a whole. So let's get into what an example of that looks like. So for a data distribution tree, here's an example where the main group, the core of the cluster, is in the group M. So that's where the high availability active nodes are. And then below that, we might have a couple of subgroups. And each of these subgroups can receive data from that upper level group. Furthermore, we've introduced a subscribe-only capability, which basically means those, we're calling those nodes in the lower group, perhaps leaf nodes in a tree, they're able to receive data from the main group. If there's a failure of one of those main nodes, that the standard BDR failover mechanisms kick in so that those leaf nodes continue to receive data in any event. And one of the things that we're doing here is to support these large distribution networks, is that we're building initial support to have up to 1,000 nodes. Again, that kind of telecom use case where there's hundreds of nodes deployed, getting up to 1,000 nodes for a cluster size is a very reasonable expectation. So that's what our design point is for this. Moving on to talk about some better observability. When you're managing a large cluster like this, you need to make sure everything's functioning, right? So there's been some enhancements in the recent release of BDR that provide some more operational insights. So we've enhanced a number of views. That information and all of the monitoring capability that we had prior to that is now expressed inside our Postgres Enterprise Manager tool. And this tool now includes three dashboards that provide visualizations of that of the metrics and the observability data that you want to see in BDR in a cluster. And I'll talk about the three of these. So first up is the admin view, and this provides an overview of the cluster in terms of just general status, software versions, the number of threads that are configured for different capabilities within BDR, as well as we'll talk about CAMO, which is commit at most once status for the cluster. So there's a lot of just overall view of what's configured for the cluster in terms of operational aspects, in terms of monitoring the overall health of the cluster. We can see how the cluster stands in terms of the the transactions, the lag in terms of replication, what the subscriptions are, and all of that. So it's a very useful way of seeing what's going on, and you can set alerts and things around hitting different metrics. And then finally, if there's an issue, you want to be able to drill into what's going on into a particular node in the cluster. There's more information here available in terms of what's happening at the node level, in terms of like what conflicts are being encountered, different rates in terms of time and bytes and for measuring lag and so on. So a lot of good visibility in terms of what's happening inside of BDR, and we'll be evolving that as we move forward as well. So all good stuff here for managing your clusters. Let's turn towards those Oracle compatible apps that have those very high availability requirements, F5 9's needs. So with BDR and EDB's Postgres Advanced combined, working together, we can bring those benefits to those top tier Oracle applications. So if you want to be able to migrate your tier 1 applications to Postgres, this now opens up that path. So we have a number of customers who've been migrating their tier 2, 3, and 4 applications over to Postgres. And now with BDR, they are looking at moving their tier 1 applications. Now, there's a lot of migration capabilities in the platform today, and there's some tooling to help enable migrations to move quickly. But again, one of the key benefits is that you're able to move quickly, and for the people on your team that have developed skills over time working with Oracle, our tools will look very familiar and be able to leverage everybody and their skills to move to Postgres. And from the perspective of your business, you're going to be able to save money, which is always a good thing, and you'll be able to move faster given the tooling and support that we have at EDB to help you move from Oracle to Postgres. And never mind the fact that every year PostgreSQL puts out a new version with new capabilities, so it helps innovation on the innovation front as well to stay current. With that, I wanted to spend a minute just to kind of come back to some of the an overview of the features of BDR, because we've been talking about some of them as we go in terms of newer capabilities. But before we go off to the roadmap, I wanted to just kind of give people a feeling for the overall capabilities, just a bit of a flavor. So we talk about these in two kind of different categories, sort of the essentials that everyone's probably going to leverage, and then the more advanced capabilities where you might use one or two of them. So from the essentials perspective, I'll start off with what Simon Riggs mentioned in his webinar last week. BDR gives you the ability to do rolling upgrades of your application and your infrastructure, and that is the number one killer for downtime, right? Like if you have to apply security patches, 4 times a year, that's going to take time, right? And having BDR in place to be able to take those upgrades on a rolling basis and not have any downtime is a really big benefit when you're talking about a particular budget for downtime, right? So that's really one of the biggest things to address that 5 nines of availability. And then, of course, out of the box, BDR is row level eventual consistency. And then we talked about some of the tools that are available. So there's a bunch of stuff just out of the box that enables your applications to have that active low downtime, very high available support for your applications. Now, some of the applications have very specific requirements, and there's some capabilities we have. So in addition to parallel apply we talked about earlier, where you can get up to 5 times the throughput, so that's helping provide the ability for you to keep up with your application, right? Keep Postgres, keep the throughput up where the application expects it. There's a feature we talk about called commit at most once. Sorry, I get the order wrong sometimes, but commit at most once. So if you have a service that needs to support an idempotent semantics, so I want to apply a payment to an account and I want it to only apply once, this is that capability. This is that capability in BDR that supports your being able to provide that type of service. Why is it important? Well, if you're a payment provider and dealing with large payments, those are like billion-dollar type of payments, you definitely want to have that kind of capability. So that's available with BDRs called Camo. There's also conflict-free synchronous replication, which PostgreSQL in the core can't do. So that's another benefit there. There's also CRDT. So if you're having multiple writers update the same data, you can be able to do that concurrently using that. And then, of course, there's the ability to configure column level conflict management and resolution. And if that's not sufficient, there's the ability to customize that as well. So if you need to have specific conflict handling rules, or if you need to do some sort of data transformation on conflicts, that's available as well. So I just wanted to kind of give you an overview of the key features that we see customers using with BDR. And now I wanted to jump to a look ahead as to where we're going in the roadmap. So most of what we talked about in this presentation has been around our recent 3.7 release, which became generally available this past May. As we move forward into the latter part of the year, we will be introducing another major version, 4.0. We're also moving to what's more standard in the industry, following the semantic versioning spec. So 4.0 represents a major release. We'll be adding support for PostgreSQL 14. And we'll be completing the integration work with our EDB Postgres Advanced server, such that the following features are enabled. So a complete feature set of BDRs available for Oracle compatible applications. That's the eager replication and Camo and single decoding worker. So those are the key capabilities. And there's also an application assessment capability that we can use as part of the development of your application to see where things need to perhaps be tuned as well. Importantly, in this timeframe, we'll also be introducing some improvements in our cluster management or connection management between the application and database, the active database, such that there'll be zero transaction lag on switchovers. So that's a key thing that provides a lot more confidence for our customers in dealing with things like large value payments. And then as we move into next year and beyond, obviously next year will be Postgres 15, so we'll be adding support for that. We'll be expanding our pipeline parallelism and also enhancing large transaction support for faster throughput. So again, going back to those enterprise requirements like faster throughput. For support of bigger tables and clusters, we'll be enhancing our auto partition support. And then, as we evolve our data distribution capabilities, this will be to support bigger clusters. And then finally, we've a long-term goal is to enable bigger databases through auto scale capabilities, which leverages sharding. In the shorter term, we'll be more focused on scaling up throughput and then more about the larger databases as a whole. So this is something that is more of a forward-looking view of where we're going with BDR. And with that, I think that's all for today. So I want to thank everyone for joining today. We do have some time for questions. I don't know if I was able to answer everything that came up, but we do have a few minutes now if anybody has any further questions.
Thank you, John, so much for the presentation. That was awesome.
Okay.
Actually, there is a question over here. What does BDR use for distributed consensus?
Oh, that's a great question. As everyone probably knows, this is based on distributed computing technology, I guess, or algorithms. So for distributed consensus, we're leveraging Raft as a way to know whether or not all of the nodes are present in a cluster. For some of those operations we have to do, like when DDL is being updated in the cluster, we will take a lock at the cluster level, and that use Raft to ensure that we're able to do that. So that's a great question. Thanks for that, Ina.
Awesome, thank you. And then the last one I have over here is, what can BDR do that core PG Logical can't?
Oh, another great question. There's a lot of, obviously, as the BDR teams contributed a lot to the core of PostgreSQL and PG Logical as well. There are some key capabilities that you need to have in place when you have a cluster operating, particularly if you're taking writes at multiple nodes. Some of those things are like global sequence handling. If you need to have, for example, you need to have a unique identifier on a row or an entity in the database, you need that sequence number to be unique across the cluster. So that's one of the benefits of BDR. DDL replication is another one that comes to mind. We did talk about synchronous replication. Postgres's core does not support conflict-free synchronous replication, and BDR does. So that's another important differentiator. And then I think the last one is that, well, because it is an active-active bidirectional replication, it does also support failover of the replication slots. So those are some key things that are differences between PG Logical and BDR. Okay.
Great. I see some questions popping up in the Q&A.
Yeah, some more questions.
Yeah.
So first, let's see, there's a question. Do you have a tool that can convert Oracle SQL code into PostgreSQL equivalent? As part of our EDB Postgres Advanced, the database distribution, it can run Oracle SQL code natively. So there is no actual conversion necessary. So that's something that is just kind of available. Let's see, another question. How to assess application compatibility with BDR? So that's a good question. We have, in a test environment, we have the ability to put BDR into like that assessment mode that can look at what sort of things are going on that may be need to be addressed in the application. So depending on the application and the requirements of the application, there may be some adjustments to either the application or BDR in terms of its configuration. And we have a lot of information in our documentation around that. And of course, we have the expertise available to help guide you through that as well, if it's a very thorny kind of thing to do. But these kind of application changes are often for people who have been doing work in the Oracle arena. It's very familiar in terms of the kinds of things you need to address in your application. Let's see. Finally, another question. Let's see. What else we have here? I'm trying to catch up on all of them. Let's see. So there's questions about tier one. So tier one applications on other databases like Oracle or SQL Server. Why are they not moving more aggressively? Well, that's I think what it comes down to is effectively we hear from customers is they need to have the confidence in the solution that it does support all of their tier one needs. So high availability being a key one there is supporting 5 nines, supporting security requirements, supporting, there's a lot of different aspects that tier one applications have over tier 2, 3, or 4. High availability is one of the most critical ones, but you can't overlook security and some of the other pieces that are present in that kind of a deployment. So customers are looking to move. These applications are the heart and soul of their businesses. They're not going to risk that, so they look very carefully at these things. And I think our experience with customers has been once they've taken BDR through its paces, then and they build that confidence, then they start moving rapidly through the rest of their application. So it's just you're talking about a high level of risk to the business, and there's a lot of scrutiny in terms of those decisions. So I think over time we'll see this expand and move more quickly. Let's see, does BDR replicate at the database level or schema table level? So BDR replication sets, if you look at take a look at the documentation, it's at the table level. So you define which tables are replicating, and there's some defaults that can basically take all of the tables in a schema, for example. Can BDR work alongside streaming replication? So that's so physical streaming replication is part of the core PostgreSQL capability. It really doesn't necessarily interact with BDR in any way, and we see people leveraging that with our for backups with Barman as a solution, right? So it's certainly it interoperates well. Is BDR available with EDB standard subscriptions? Yes, BDR is. So for folks who are familiar with EDB's subscription plans, the standard and enterprise plans also have the ability to incorporate BDR as well. So that's something for folks who are familiar with EDB. Let's see. I think there's a question about cloud native Postgres operator. So folks who are in a Kubernetes environment, it's a great question. I love this one. I love Kubernetes. It's definitely where a lot of organizations are going. There is a Kubernetes operator coming. I meant to include that on the roadmap, but ran out of room. So that'll be coming later in the year. So that'll be available as well. So thanks for bringing that question up. All right.
Cool.
I think we covered everything. So.
Yep, that's
great.
all good. So thank you, John, for the presentation and answering the questions. And thank you all for joining us for this webinar. As I said in the beginning, we'll be sharing the recording and the slides as soon as possible. So with that said, have a wonderful day.
Great. Thanks everyone for joining. Have a great day.